Well, hi there, boys and girls. Let's take a look at what we know so far. If f prime is positive for all values of x in an open interval from a to b, then we are going to say that f is increasing on that interval. We're going to use the closed interval for that. It begins increasing at a and stops decreasing at b. Then if f prime is less than 0 for all values of x in an open interval, then we are going to say that f is decreasing on that closed interval. Then if f prime is equal to 0 for all values of x in a to b, then that thing is probably a horizontal line. F is constant on that closed interval. That's what we learned yesterday. We also learned a few other things. This would imply that we're going to create some relative extrema if f prime happens to change its mind. If f prime changes from positive to negative, we go from increasing to decreasing at x equals c, then we are going to know that this point, where that happens, that's going to be a relative maximum of f. And then if f prime changes from negative to positive at x equals c, that means that f was decreasing and then going to increasing. So if f prime changes from negative to positive, then we are going to have a relative minimum of f. Alright, so let's take a look at an example here. Find the intervals where f is increasing and decreasing. Let's go ahead and annotate this. If f is increasing, I need f prime to be positive. And if f is decreasing, I need f prime to be negative. Also, identify all points that are relative maximum. We need f prime to go from positive to negative for that to happen, and for a minimum I need f prime to go from negative to positive, and then we have to give justification. Well, my justification is going to be exactly what I just notated right here. Alright, well, I've got a piecewise function, so I better make sure that this thing is at least continuous. So let's check continuity. Is this thing a continuous function? So let's check f of -1 at this special breakpoint from the left and from the right. So we're going to plug in -1 for x and see if they match. Alright, so from the left I get 2 times -1 plus 1, which is -1. Now from the right, which is using the bottom graph, I get -1 squared minus 2, which is, well, that's also -1. Okay, so we are continuous. So let's see if we can take a derivative. What would f prime of x be? F prime of x would also be a piecewise function, and it would be 2 if x is less than or equal to -1, because the derivative of 2x plus 1 is 2, and f prime is the derivative, or the slope of 2x plus 1 is 2. Now f prime would be 2x if x is greater than -1. Now let's check and see, is this differentiable? In other words, do the slopes match? Well, to the left we have a slope of 2, and to the right, if you plug in -1, we have a slope of -2. That means this is not differentiable. They do connect because they're continuous, but however the slopes aren't going to match. That's going to tell me something when I try and graph this. So let's take a look at our critical numbers, or our critical points. That's where f prime is 0, or where f prime does not exist. DNE. So where does f prime does not exist? Well, I just figured that out. At -1 it's not differentiable because I've got different slopes from the left and from the right. So f prime does not exist at -1. Are there any places where the f prime is 0? Well, 2 is never equal to 0. However, 2x equals 0 whenever x equals 0. So I've got two critical points to check. So I'm going to draw my number line, and I'm going to go through this organization on this sign chart, and then we're going to see what we can tell about f. So I'm going to put on my number line, I'm going to put -1. That's a critical point because f prime does not exist there. I'm also going to put a critical point at 0. And I'm going to test values for f prime, which should tell me something about f. So let's plug in -2 for f prime. Now -2 is in this interval right here. So if I plug in -2, I get 2, which is a positive number, which says that f is increasing because f prime is positive. Now let's plug in a number between 0 and negative 1/2, like between 0 and negative 1, like negative 1/2. Here, anything that's bigger than negative 1, I have to use this equation. And if I plug in negative 1/2 for x, I get negative 1. That means that f prime is negative, saying that f is decreasing. And then if you plug in a number past 0, like 6.1, doesn't really matter, I plug it into this equation, I get a positive number, which means that f is increasing. So we are going to now see what happened. We can see our max and mins there as well. So let's make some statements. Let's say that f is increasing on the interval negative infinity to negative 1, also from 0 to infinity, because, what is my because? I've got it right up here. This is my because for increasing. Because f prime is positive on those intervals. Now let's say that f is decreasing on the interval from negative 1 to 0. And you know what? I can use negative 1 here. But what I really, and I can also use 0 here. Now this is going to be an interesting difference. Am I going to use parentheses or brackets here? I'm going to keep this as parentheses because I've already said it was increasing up to there. You're going to find out that it's not really going to matter if we use parentheses or brackets. So I'm going to say that f is decreasing on parentheses negative 1 to 0. I just don't want to put brackets on both of them. I guess I get to decide when it starts increasing. I don't know. F is decreasing on the interval from negative 1 to 0 because f prime is negative on that interval. Now what else do we have to do? I have to do the relative max and relative mins. What does that mean? Let's see. Relative max occurs where f prime goes from positive to negative. Did that happen? Well, looky here. It happened right here, and you can even see that little maximum value. So f has a relative maximum at x equals negative 1. Why? Because f prime changed from positive to negative there. Plus 2 minus. Now what else happened? Well, at 0 I created a minimum. F has a relative minimum at x equals 0 because f prime changed from minus to plus. Now I have to sketch a graph of this thingy with all of that information up there. So let me go grab a line and see how we can do with this. I'll grab 2 lines. Alright, so we were increasing until we get to negative 1, so that's pretty important. Negative 1 is important. We also have a minimum value at 0. We have a maximum at negative 1. So I think that's really all I need to do this. And I can tell from this equation that to the left of negative 1, it's the line y equals 2x plus 1. So that is going to look like it's increasing. And then, by the way, if you plug in negative 1, we already know that that y value is negative 1. So right there, that's negative 1. And then all of a sudden we turn to the quadratic, the x squared minus 2 thingy. And on top of that, we have to create a sharp turn. And we have to decrease down to 0, and then we have to increase everywhere else. So the graph looks something like that. There's that sharp turn, that non-differentiable point. Alright, so let's use this graph that we're looking at, and we are going to label this 3 times. Graph of f prime. This is f prime. I am looking at f prime. 1, 2, 3, and label it 3 times. You better know what that means. F prime. This graph is f prime. It's going to make a big difference. If I thought I was looking at f, my answers are going to be way off. Alright, so let's identify the intervals on which the graph of f is increasing. So let's annotate here. That means that f prime would have to be positive. As a graph, that means it needs to be above the x-axis. For f to be decreasing, I need f prime to be negative, which means f prime has to be below the x-axis. And then for a relative maximum, I need f prime to go from positive to negative, and for a minimum I need f prime to go from negative to positive. So that's what all of that stuff means. So let's justify our answers, and we're going to see that in just a second. This is our justification. So where is f increasing? F is increasing everywhere f prime is positive or everywhere f prime is above the x-axis. Here is a pretty picture of f prime. Where is f prime above the x-axis? That's going to be, I'm going to use parentheses now. I'm going to say from negative 3 to 1 unioned with 4 to infinity, f is increasing on these intervals because f prime is positive on those intervals. And then let's do decreasing. That's where f prime is negative or below. I'm just going to show you that you can use parentheses as well here. On the AP exam, that's not going to matter very much. We just don't want to ever include a point where it's undefined. So I'm going to use parentheses, and I'm going to say that it is below from negative infinity up to negative 3, unioned with 1 to 4. F is decreasing because f prime is negative. Now what else do we know? We know where f has relative max and mins, where f prime changes sign. Where does f prime change from, say, plus to minus? That means above to below. Where does that happen? That happens right here at 1. F prime is 0 there. Do you know what else that makes that point? That makes that a critical point. So at 1, f has a relative maximum at x equals 1 because f prime changed from positive to negative. I didn't have room to write change, but I should have. And then we've got 2 minimum points. So I'm going to say f has a relative minimum at x equals negative 3 and also at 4. There's 2 places because f prime went from minus to plus there. And I should have written that out better, but I ran out of room. I hope that I've modeled that enough for you. I'm gonna write. Really need to be writing that as a complete sentence. All right, so let's take a look at a couple last examples. We've got some information here. If g of x equals 2 times f of x, what's the sign of g prime of 1? So I'm going to get what g prime of the letter x is first, and that would be 2 times f prime of x. So g prime of negative 1 is going to equal 2 times f prime of negative 1. So let's see if we can figure out what f prime of negative 1 is. Let's see, I'm dealing with the x value negative 1, so that interval does not help me. But this interval right here helps me. Between negative 3 and 2, f prime is positive. So that means I'm doing 2 times a positive number. Therefore, the sign of g prime of 1 equals a positive number. Now what if g is f of 3x minus 5? What's the sign of g prime of negative 1? Well, let's get g prime of the letter x first. That would be f prime of 3x minus 5 times 3. You see how I throw a chain rule review in for you here? You remember when chain rule was the end of the problem? G prime of negative 1 would then be f prime of 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8 times 3. So let's see if we can figure out what f prime of negative 8 is. Well, I will now need this interval, and it says that f prime is negative on that interval. So I would get a negative times the positive number 3, which is a negative number. Alright, so let's do this last a, b, and c here. I've got a function s of t, describes the motion of particle along the line. Find the velocity function of the particle at time t is greater than 0. Greater than or equal to 0. Well, the velocity function is going to be the first derivative of your position function. We're going to say that a whole bunch this year. So that means I'm going to take the derivative of my position function, which is going to be 2t minus 7. That's my velocity function. So I could find the velocity anywhere I'd like. Now we want to find the intervals in which the particle is moving in a positive direction. That means for the s to be moving in a positive direction, I need to have the velocity has to be greater than 0 or positive. So let's take a look look at the critical points for a position, which would be where this first derivative equals 0. That happens at 7/2. So let's check the velocity here, which will tell me something about the position. So let's plug in a number like 0. If we plug in a 0 to our velocity, I get a negative velocity, which means that my position is decreasing. And if I plug in a number like 5 into my velocity equation, I get a positive number, which means that my position is increasing. So my answer to this is from 7/2 to infinity, because v of t, which is equal to s prime of t, is greater than 0 on that interval. Part C says identify the time intervals in which the particle is moving in a negative direction. Well, I have all of that information up here, so I'm going to say that is from negative infinity to 7/2, because v of t, which is equal to s prime of t, is negative on that interval. And then the time at which the particle changes direction, that's going to happen at t equals 7/2, because v of t changes from positive to negative there. Actually changes, if we're reading left to right, changes from negative to positive. Anytime your velocity changes its sign, you're going to be changing your direction. So anyway, I hope that we got some practice with that, and I will see you guys tomorrow.